Thank you. So, today I'm going to talk about introduce the M star double plus C. So I'll define MM star double plus later. So first, let me start from introduction. Okay, so let's start from forcing. So the forcing is a universal machinery in set theory, like to construct a strong theories extending ZFC. And in forcing, we have two methods. So one method is forcing over a model of ZFC. And with large guardians, and there are many results in this approach, but since we would like to focus on Martin's maximum, so I give a result by Foreman, Magida, Scheller. So Foreman, Magdor, and Scheller. Okay, they prove that MM hold true in a forcing extension of model of ZFC with a supercompact cardinal. So ZFC is a supercompact. Okay, and another approach is forcing over model of determinacy. So, over model or determinacy. Okay, so this approach starts from the result by Steele and Van Besep. And Besep. Okay, so they obtained the saturation of NS omega 1 from a model of ADR plus theta is regular. Equation of NS omega 1 from ADR plus theta is regular. Okay. And later, Woodin introduced the Pmax forcing and its variant, and he proved and he forced the following result. Okay, the first one is a bounded Martin's maximum double plus. It's a bounded version of Martin's maximum double plus. And it's from essentially AD plus the global closure under M1 sharp. So closure under M1 sharp. Okay. So to force BMM, you need an additional structure beyond parset of R. And also, he forced MM double plus C. This is a Martin's maximum for for the poset with size continuum from ADR plus theta is regular. Okay. And recently, Larson and Sarkisian forced failures of square. So Larson and Sarkisian and forced the failure of square omega 3 and omega 4 from a strong model of determinacy. It's a Chang type model, I think. Yeah, okay. We have two approaches. One is forcing over a model of ZFC with large cardinals, and the other is forcing over a model of determinacy. And recent result by Aspero and Sindora, actually the two approaches are connected. So prove that MM double plus implies Wittin's axiom star. Okay. So this is a general picture about two approaches. And one main question about forcing over model of determinacy is that, okay, can you force MM double plus over model of determinacy? So the can MM double plus hold true in okay, let's say Pmax extension over model of determinacy. Okay. So this is a main question about forcing over model of determinacy. And let me remark, if the question is yes, we would get a model of MM double plus with Wittin's axiom star double plus. If not, I don't know. But our main result gives the partial result for this question, and it is a best partial result as of today. So, okay. So, do you have any question so far? Okay. So, okay. Let's finish backgrounds, and so let's talk about MM double plus. So, okay, so let me define MM star double plus. So it is introduced by Aspello and Sindler, and the motivation comes from omega logic and Pmax forcing. So, okay, and of course it is a strengthening of MM double plus. So, fine. Okay, before introducing MM star double plus, I define honest consistency. So let phi be a formula in the language of set theory, and we add additional predicate for ns omega 1. So it's I write ns omega 1 dot. So we are giving formula, and also we are giving some structure m, and with omega 1 many languages. Here structure. Yeah, giving a structure. Sorry, I'm confused. So it's definition of honest consistency. So okay. Okay, now we're giving just any set. So let B be any set. So the set B will be a parameter. And now we say the phi of B is honestly consistent. Honestly consistent. Okay. If now we are giving any universally bare set, so for any UB set A, then there is a transitive structure N. So there is some transitive model N of ZFC minus, and N satisfies the following condition. The first one, okay, the first one is that, okay, so we are giving universally bare set A, and we require that N is A closed. So N is A closed. Okay, right here. Okay, the second condition is okay, N contains first B, and also power set of omega 1 of B. This is in N. And we require that N computes the stationarity of in B correctly, namely the ns omega 1 of N sorry, I forgot. So okay. There is some transitive model N and in some collapse extension. So I just forgot. So there is some transitive model N of ZFC minus in some collapse extension, so called omega theta. Theta is sufficiently large. Sorry, I forgot. Touch that. Okay. So yeah, N is A-closed, and N contains enough parameters, and N computes the stationarity in B correctly. So the ns omega 1 of N intersect with B is ns omega 1 of B. Sorry?
What is theta?
Theta is sufficiently large collapse. So yeah, if large enough, like bigger than B, for example, and collapse. And okay, then N satisfies phi of B. So is okay, N satisfies phi of B. Okay, so roughly speaking, phi of B is honestly consistent if there is some outer universe of B. You may find a model N which is reasonably close to B, and also, of course, the N satisfies phi of B. This is the definition of honest consistency. And now, A closed means, okay, A is closed on the extension of A. So any set generic extension of A is closed under A. So A is universal Abelian set, and we extend A, and N contains a name for A. Yep. And now define. Okay, so let kappa be cardinal, then M star W plus kappa is a flowing statement. Flowing statement. Okay. So now we are giving formula. So for any, so now we stick the sigma 1 formula. So for any sigma 1 formula, be in the language of set theory with additional predicate for ns omega 1. And now we're also giving structure any M. Okay. M is any structure with omega 1 many languages. I. Okay. D for any. This is structure. And kappa stands for the size of M. So the structure of size kappa. Okay. And now, if the statement C of M is honestly consistent, yes, consistent. Okay. Then in B, phi of there is some smaller structure M tilde. So then in B, there is some M tilde. Okay, M tilde can be M tilde elementary embeds into M, so which elementary embeds into M, and phi of M tilde holds true in B. Yasuda goes to in Q. Okay. This is a statement of MM star double plus. Okay. And let me remark some fact about MM star double plus. Mark. Okay. So first, so MM star double plus is a statement that for any couple, MM star double plus couple holds. And the first remark is it is actually strengthened. So MM star double plus implies MM double plus. Okay. But we don't know its consistency. So okay, it is not known the consistency of MM star double plus even from large cardinals. So from and of course we don't know about the reverse implication. So this is a definition of MM star double plus, and now we state our main result. Okay. Theorem. Oh, I think I forgot to say this is a joint work with my supervisor, Ralph Schindler. Schindler and me. Okay. Okay. So you can characterize MM double plus by changing here by, okay, you're giving sigma 1 formula phi and also structure M. Then you change the here by just phi of M holds true in some stationary set preserving extension. Then you can find some M children, blah, blah, blah.
You don't, is this a ZFC implication?
No, it's just ZFC implication. Yes. But it's subkappa. So subkappa is for we restrict the size of anti-chains, not the size of poset. Yep. Okay. And our main theorem is that, okay, MM double plus at continuum holds true in the Pmax. Okay, we get off ZFC. Holds true in the first we do Pmax, and after we add Cohen subset of omega 3 to fourth choice. Add omega 3 of 1 extension, and in a model of determinacy. Okay, so as I said, this result is the best partial result about this question as of today in the following sense. So, okay. So first, we don't know how to force MM star double plus C but from a model of ZFC with large cardinals. So it is not known how to force MM star double plus C from ZFC. And we don't know how to force MM star double plus C plus over model of determinacy. So so same, and for force MM star double plus C plus from determinacy. So this is our main result today. And the rest of my talk, let me sketch the proof of this main theorem. Yeah, I will explain. Yeah. So, yep. Okay. Actually, we extracted the determinacy axiom to force mm star w plus c, and the main theorem can be split into two parts. First is to construct the ground model, and the second part is to force mm star w plus c. So just I combine the two theorems. Okay, so our determinacy axiom is following. T0 is AD plus ADR plus theta is regular plus every set of layers is universally bare. So every set of layers is UB. And we add some technical assumption. So, okay, this is gamma infinity is productive. Okay, so this is a technical assumption which we need in the proof of the main theorem. Yes, but okay, this is our determinacy axiom today. Yes, so this is actually simple. So, okay, gamma infinity is productive if for any A. Yeah. So, okay, I'm not. Yeah, is it okay? Yeah. Here? Yeah, the problem is that I'm not so tall, so, okay. There it is. Okay, the productivity says that, okay, we have two operations. First is taking extension in some set generic extension, and the other operation is a projection, just taking projection. And productivity says that, okay, they are compatible. So for any A, the first we take a canonical extension, and after that we take projection. This is the same as a canonical extension of projection in any set generic extension. This is a productivity. Why do we need that? We need generic absoluteness for the projective statement in universal bare sets. So that's why we need this statement. Yes, thank you. And of course, under large cardinals, okay, as in proper class many Woodins, then this is automatic. But just, we don't know, we can prove it from only assuming every set of layers is universally bare. The similar question was asked in the paper by Feng, Magda, Woodin, so it's still open. Yes. But okay, so yeah, it's true, yeah. Okay. Yes. Sorry? Yes? I don't think so, because we simply have okay, okay, well, later, but okay. So, okay. So first, I give you a ground model construction. I think there are several ways to construct it, but okay, I like to use derived model construction. So okay, ground model. just basically we combine two known results. First result is by Larson and Sarkisian and Wilson. Okay, so they constructed kind of generalized derived model for universal for every set of layers is UV, and so they get the model of AD plus ADR plus every set of layers is UV. So I abbreviated UV just. And so we need theta is regular. So and we use the result by Gappo and Sarkisian. Okay, so the theorem states that okay, if you construct the derived model over Hod mice, then you get theta is regular. So it's okay. It's theta is regular. Yeah. Mm-hmm. Yes. Yeah. So, and to construct ground model, we combined two methods, and actually we proved that in the generalized derived model satisfy T0. So the productivity is a bit non-trivial, but we can prove it. And our model is of the form, so I write M. This will be a L of FUB. FUB is some predicate, and the base set is possible R. Okay, this is our model and satisfying T0. So FUB is a predicate, and it tells you how to extend universal real sets in generic extension. So yeah, essentially it calls some certain forcing relation, and from FUB you can extend any universal real set in forcing extension. So yeah, this is our ground model, and so let's prove star W plus C. So I need more spaces. Yeah, okay. So we will be giving some sigma 1 formula phi and also the structure M. M of size continuum. So for simplicity, so we assume M is a structure, some structure on R. And also the statements in the statement we force adding Cohen subset omega 3 after Pmax, but it doesn't matter. So we only focus to show that star W plus C holds in Pmax extension of M. Yeah, forcing choice is the result by Budin. So we can force choice. So let's show star W plus C holds in Pmax extension of M. So yeah. So fix some name tau, Pmax name, name for, as I said, a structure, name for a structure on R. So on R. Yeah, essentially tau is a name for the structure of size continuum. And since the Pmax forcing is sigma closed, and each Pmax condition can be coded into a real, so we may construe tau as a set of reals. So we construe tau as a set of reals, as a set. Set of reals. Okay. Okay. So here comes a central notion, important notion in the proof of the forcing part. Okay, we say a pair P and H is tau good. So tau is a fixed name for a structure on R. Okay, yeah. So the tau good. If the following condition hold true, so the first condition is okay, P is Pmax condition, and it is a tau iterable condition. So we consider tau as a set of values, so it does make sense. P is tau iterable. Okay, the second condition is about H. So first, H is element of P, and it is a filter in Pmax. In Pmax. And P is a master condition for H. So namely, is less than Q for any Q in H. So yeah, P forces that H is some small generic inside of P. And the last condition is about H. So we require that H meets enough dense sets of Pmax, enough dense sets so that, okay, so suppose we force be a P, so if G is Pmax generic with P in G, okay, then the Pmax generic induce the generic iteration on P of length omega 1 plus 1. So let's say it's I of G. And we iterate P star, and the length is, okay, omega 1 plus 1. This is induced by Pmax generic G. Okay. Then the following holds. So, okay, since P is tau iterable, so P has a own name for a structure coded by tau, and also P has a local generic H. So we interpret that structure by H. So namely R intersect with, okay, the base set is a set of layers appears in I of GH. So union of I of G of H. Okay, this is a base set, and the structure comes from tau. So I of G tau intersect with P, interpreted by I of GH. Okay. So from P, it's from P, but iterate of P, so namely P star. From P star, we have some structure named this structure, and we require that it is elementary substructure of the original structure. So R of G. So I like R of G, but it's just set of layers in Pmax extension, and the structure is R of G. So okay, so the target pair has its own structure, and if we iterate it by a Pmax generic, it will produce a elementary substructure of the original structure. This is a definition of goodness. Okay, and 10 minutes. Okay, then. So now, okay, let's.
Maybe.
Okay, then, yeah. Okay, I'll give you the list of details briefly. So okay, so now suppose that okay we force over M by a Pmax. So G is a Pmax generic, And now suppose that, okay, the statement that phi of R of G and tau of G, so this is our structure for M. And the statement about this structure phi is honestly consistent, okay. Okay, so here it's, okay, suppose. Okay. Okay, so now suppose the statement is honestly consistent. So yeah, so the inside of large enough collapse extension of M of G, so the name called omega theta. I don't like this. So since, okay, by definition of honest consistency, we have some small universe n satisfying the statement P of Rg and tau of G. Okay. So, and our goal is inside of this extension, we will produce a good pair. We will produce a Q and G. So the G works for the H, right? Because G is generic over M. So our goal is inside of the extension, we will find some Q and such that Q of G is tau good. Here I confuse set of layers in ground model with canonical extension, but here it doesn't matter. So we have G for H, and we want to find Q. How do we find that? It's using gamma Woodin argument. So okay, so I'll give you quite rough details. So first, okay, fix smaller substructure, transitive structure X, G, tau G, and it contains everything relevant. And okay, so and first go back to ground model. Since tau is set of layers, so by using gamma Woodin argument, we find mice nj which captures sigma. So let's say W. By gamma Woodin argument, we find mice which captures tau. And again, by gamma Woodin argument, gamma Woodin, yeah. And again, by gamma Woodin argument, we show that the operator, namely the X operator, which M2 sharps J operator, is defined. And so, yeah, in the definition of honest consistency, we need to feed universal Lebesgue sets, and we feed n to f to n. So this is our universal Lebesgue sets, but we feed graph of f. But so yeah. So first, okay, our universal Lebesgue set is f, and n is f closed. Then the base set for Pmax condition is P, which is M to sigma J of X. So since we have routines, we use the first routine to make it Pmax generic, and the second routine is we need it to show that the condition is tau iterable by genericity iteration. The last case. So we found a structure Q and G in the collapse extension, but the existence of such pair is projective statement about tau. And now by using productivity, so we have enough absoluteness, so we find a good pair P and H in the ground model, and also it satisfies P of the P statement. Here comes a structure like that. So yeah, we show that there are densely many good pair P and H which satisfies Phi of the internal structure, and it is enough to and it shows that in Pmax extension, MM star double plus C holds. And yeah, thank you.